let us just dive into the question. So example 7, right? Example 7 says the following. Consider the given diagram, right? So this given diagram, it says consider the given diagram. Say CAN. C A. Where is A now? What? Oh, up here. Hey, goodness. So they said we should consider this diagram CAN. They should have just said CNA or something, but these guys are boring. So they say that this diagram is drawn, it's a triangle. And then it says CA has a y-intercept there, which is also the midpoint of UN. Okay, so UN has a midpoint. U is not given at all, but then N is, half of N is given. And then it says AN, A going to N is 3 square root of 10. Then it says determine the value of A and B. Okay, so we should get the coordinate of, we should technically, like if we look at it, you know, hypothetically speaking, we should technically just get the equation of, no, we should just get the coordinate of C and the coordinate of N. And this is strange. It says let the y-intercepts of AC. So this is let the y-intercepts of AC and P, what is it saying here? Where is P? Oh, let the y-intercept of AC be P. Highball. So P is this point. Okay, they're giving it a coordinate. So they gave this a coordinate 0, and 2.5 is just 5/2. And then they said here, 2 methods can be used to find A. Okay, fine. We'll just see whatever it is that we're gonna do to get A. But then for A and B, right? Normally, if you need to find, you know, a random point, you see here we should focus on just how this is just an X coordinate. This is just a Y coordinate. However, the fortunate thing is, I mean, like anytime you need to get a coordinate, your coordinate is 99.99% of the time going to be on a line. So the fortunate thing is, I mean, for AC, for AN, it doesn't look like AN is going to be a hassle because we have the distance of AN. So because we have the distance of AN, we will be easily able to use the distance formula, right? For B. Since you technically have all the information you need here. X1 and Y1, X2 and Y2, and then here you have the distance. You see, so only one thing is missing from the distance formula, which you will be able to get B there easily. So I think with getting B will be fine. To get C, it looks as though for C, we might as well just get, I mean for A, looks as though we might as well just get the equation of line AC, of which getting the equation of line AC, we can just get the gradient of this line, because the gradient of this line is the gradient of the whole thing, extended all the way to C. So we can get the gradient here using these two coordinates. We have the y-intercept, so we'll have the full equation of the straight line. And then in that equation, we can just put in -4 where y is. So to do that, I think we can start with AC. So the equation of AC, we know that we can just say y minus y1, let's go to m x minus x1. But then we need m first. You see m is going to be equal to 7 minus the 5/2 there. And then 6 minus the 0. And then what does this give us in the calculator? The calculator is like far. It's like super far. I don't even want to lie. It is far. Wait, let me just see what the calculator says.
The calculator says that it's 3/4.
93/4.
Yeah.
What? That's weird. Are you sure?
Is it 9? Oh no, 3/4.
I'm getting. Oh, okay. Yeah. was like 93/4. Oh my goodness. What did I just write down? So we have the gradient, perfect. Now we just need a coordinate that the line passes through. Or we actually don't even need this because we can just jump straight to this format because we have the y-intercept, it's 2.5. You see, so here we can just say y is equal to 3/4x plus the 5/2, which is just 2.5. I don't know, fractions are just a preference, but yeah, we keep moving. So to get a, we can now just use this equation. We have the x value, which is a -4, the y value is a. So when we see y, we can put an a. When we see x, we can put a -4. And then we have here -12/4 plus 5/2. This is like a. In the calculator, I think we're getting -12 plus 10/4, which is like -2/4, which is -1/2.
Yes.
Does that look accurate? Yeah, it kind of looks a bit weird, but if this is -2, this is going to be a bit higher. So -1/2 is what we're getting, which is fine. For B, we said we can just use the distance formula. So in our distance formula, we know that distance is equal to square root. You can start with x or y, it doesn't matter. x2 minus x1 squared, y2 minus y1 squared. Now here we can make this, we can say here b minus 6. So let's see here. B minus 6 squared. And then here, -2 minus 7. -2 minus 7 squared. This is equal to 3 square root of 10, 3 square root of 10. I mean, the next step here, we might as well just square both sides so that we have this number squared is going to be, let's just write it first like this. Squared. This thing here. -2 minus that is going to be -9. And if we square that, the square root is going to be cancelled out. Then we have b minus 6, two brackets that look identical. So, yeah. So far, so good. 3 squared is a 9. Square root of 10 squared is a 10. So this is a 90 because of our exponential laws. Our exponential laws will always tell us that if two things are being multiplied together, an exponent goes for each of them individually. So here b times b squared, -6b, -6b, plus 36 plus 81. And then what? We have like b squared minus 6, 12b. 12b. What is 36 plus 81? Some number that ends with a 7, I guess. Maybe like 117. Maybe, maybe not. I guess we'll never know. No, 127. No, 117. 117, right? Ooh, I'm playing with fire
Yes.
here. Playing with smoke. So anyways, everything on one side, we're going to have b squared minus 12b. This is like 117 minus 90. What you're going to get? Let me see. 117 minus the 90, right, is like 27. So it's like plus 27. Okay, of which factors of 27 that give it 12. Let's see, 1 and 27, not gonna work. 2 doesn't go in there. 3 and 9, bingo. So let's see, we have a 3 here and 9 here. To get a -12, it has to be -3 minus 3, or -3 minus 9 rather. And then this first bracket is equal to 0, or the second bracket is equal to 0. Which is telling us b is equal to 9, or here b is equal to 3, which is nice. and we have to pick which one is accurate. So we can compare it to like the A, right? Because the X value here is a 6, so this has to be below 6. So here B has to be what you may call, has to be 3. And then that is the way we shall get it. Here they said there are 2 methods of getting A. Oh. Well, I mean, like we used the straight line way of doing it. Another method, what other method could we possibly have used? Well, I mean, like if we cannot think of it now, it almost doesn't matter because in the exam, you only just need one method anyways.
Yeah. The other method
Yeah.
is to determine the equation through points A,
The what?
P, and C. It's to determine the equation through point A, P, and C, and then substitute C into the equation.
Is to get, I don't know why I was distracted while you were saying that. And you said it twice already. It's kind of sad that I have to ask for the third time. What?
Sorry. Determine the equation through points A, P, and C first, and then you substitute C into the equation.
Okay, that's the
Yeah.
first method, which is the one we did there. And then the second one?
Oh, no, it's the first method, that one. That one is, okay, and then there's the A, P, and C are collinear points, so you find the gradient.
Oh, yeah, you can use the gradient formula to get C. Oh, yeah. Because in the gradient formula here, you already know that the gradient is like 3/4, right? So you could use A and C. So you can say like what you call A minus 7, and then -4 minus 6, -4 minus 6. Then down here, you're gonna have -10, A minus 7. And then you can just cross multiply here, -34, and then A minus 7. This is like 4A minus 28. If you take it to this side, it's going to be positive -2, 4A, and then A is going to be -0.5. Oh, nice. Very nice. Very nice. So very nice. We shall move on to the next question then, as we
Yes.
should.